Scikit-Learn is a Python machine learning library. It is one of the most useful and robust libraries for machine learning. It provides various tools for machine learning and statistical modeling, including preprocessing, classification, regression, clustering, and ensemble methods. The library is built upon NumPy, SciPy, Matplotlib, and Pandas. The following are required or recommended. You have to install Python 3, NumPy, SciPy, Matplotlib, and Pandas. Pandas is for data analysis, and you may try to use Seaborn for visualization. For Scikit-Learn installation, for example, on Ubuntu, you may try to use this command. If you install using sudo, then you can install it system-wide. There are 5 main steps in machine learning. 1. Selection of features. 2. Choosing a performance metric. 3. Choosing a classifier and optimization algorithm. Number 4. Evaluating the performance of the model. And finally, you have to tune the algorithm well. In practice, each algorithm has its own characteristics and is based on certain assumptions. No single classifier works best across all possible scenarios, which is the no-free lunch theorem. It is always recommended that you should compare the performance of at least a handful of different learning algorithms to select the best model for the particular problem. Here is reasons why you have to or you can use Scikit-Learn. It is nicely documented and has wide usability. The library covers most machine learning tasks, preprocessing modules, algorithms, and analysis tools. If you want to get a robust model, then given a data set, you may compare algorithms and build an ensemble model. Scikit-Learn scales to most data problems. Overall, the Scikit-Learn is easy to use, convenient, and powerful enough. Here is a simple example code. Using Scikit-Learn, you can easily upload a data set, and there are some built-in data sets. So here we chose the iris data set, and you can get some extra information and print out. And also you can create model instances very easily. After importing logistic regression and k-neighbors classifier, we create here the model instances. And LR is for logistic regression, KNN is for k-neighbors classifier. And also you can do it here quite easily for splitting and training and test. This will be very useful. Train, test, split. And now for the data set, we get the feature vectors and labels, and iter 100 means we'll try to run 100 times of the these models, and then try to get average accuracy. So in each iteration, we split the data set into two portions, train and test, with a test size 0.3, which means 30% will be allocated for test and the 70% for train. And this split is working with random shuffling, so that randomly separated. And after splitting the data set by using training set, and we fit, that is training, and score, that is getting test, and the output is accuracy. And we save in each iteration, and we try to get mean and standard deviation and print out. Okay. Once a new sample comes, then we can easily predict. And for example, now synthetic sample is made, and here prediction is quite easy, and we can print out and with the target name, real target name, rather than labels 0, 1, 2. Okay, that is output. These are future names for the data set. These are target names. And in label, we can see 0, 1, 2, but original target names are these three. This is average accuracy for iris data set. For logistic regression, we have this average accuracy. For KNN, we have this one. So KNN is slightly better. Now for new samples, your logistic regression and KNN predicted for the second one the same, but for the first one differently. And depending on the algorithms, you can get different predictions, and so that the accuracy can be different. But you can combine those algorithms. In Scikit-Learn, particularly with ensembling, you can finish most machine learning tasks conveniently and easily. We'll deal with ensembling in the next section. Okay, that's the end of the section. Thank you.